first part of this question is basically asking you to write x squared plus 8x plus 3 in completed square form. That's what this thing is. And let's just backtrack. I don't know why, I like to just talk about where completed square form comes from rather than just sort of telling you the method of how to do it. Well, we want to basically make a square, and you can do that with the x and the x because that gives you x squared, but we don't have that. We've got x squared plus 8x plus 3. Actually, it turns out you can ignore the plus 3 because that's not part of the completing the square bit. I somehow need to complete the square using this 8x. So I'm going to have maybe a rectangle here and a rectangle here and then a little missing bit. Now how can I get this rectangle going? Well, it's got a length of x here, but if I make this 8, then I'm going to have 8x, and then what on earth is that going to be? It's not going to, I'm going to have something else involving x. So how can I make them the same? Because I need the length to be the same. Well, I can have that 8 and I can make this 4 and this 4, and then I get 4x here and 4x here. What I basically got so far is x plus 4 squared, except I don't, because I've got this missing bit. This missing bit is 16 because it's 4 times 4. So what I have with my x squared plus 8x is I have this x plus 4 all squared, but then I'm going to have to minus the 16 to get rid of it and just leave me with my x squared plus 8x essentially. So what I can do is I can write that this is equal to x plus 4 squared minus 16, and then I still need to add my 3 at the end. But my point is that x squared plus 8x can be written as this. Now as you master this approach and maybe memorize it, you learn that you just basically have the 8 to give 4, you put that inside the bracket, and then you basically square it because you're timesing it by itself, and you need to minus that because that will bring you back to the thing that you have without the constants. I then worry about the plus 3 afterwards, so basically the final answer is going to be x plus 4 squared, and then I need to do minus 16 plus 3, that's going to be minus 13, and I've written it in completed square form. Right, I'm now being asked to sketch the graph of this, show clearly the coordinates of any turning points and the y-intercept. Well, we get the y-intercept really easily. It's actually just this thing here. It's when x is 0. It's a bit like when you have y equals mx plus c. So I know it's going to go through 3, and I'm going to put a little cross and a 3 there. Now what else do I know? I know that it's going to be a happy quadratic because it's x squared. It's going to look a bit like this. I've drawn the face, but it's not actually going to have a face. And because a sad quadratic would be like this. I think I've focused too much on the face here. It's actually this is the curve that I'm interested in. Now I don't know if it's going to come down like this or if it's going to come down like this. So we need to really focus on the turning points, and that is where completed square form comes in, because as we saw at the start, that curve y equals x squared plus 8x plus 3 can be written in a different form. It can be written in this completed square form. And here's the thing, this square must always be greater or equal to 0. It can never be negative. And so the smallest it could be would be 0. And that means this thing as a whole has got to be greater or equal to minus 13. It can't be any less than minus 13 because this thing on the left is always positive or 0. So it's equal to 0. That's going to be the minimum. Sorry, that thing is going to equal 0 when x equals minus 4. Because that's what will make it. But when x is like minus 5, actually it will be positive. So I need minus 4. I need to take the negative or whatever's here to give me that. And then the whole thing, the minimum, is then going to be minus 13. So basically the turning point is going to be minus 4 minus 13. And we're well on our way way now because I can just draw it. It's going to be like down here, and I'm gonna label it -4, -13, and I'm sorted. I can now draw my quadratic because I know it's going to come down and go through that thing there, and it's going to hit it, and it's going to come back up. Now that wasn't very good. I can do better than that. Let's have it like this. So, although now it's gone off the axis. Okay, one last little try because I think I should probably just move it along a little bit to make it all fit in. Okay, this. Here we go. Here we go. Right, it's going to cut. We've got to try and make it symmetrical as well. But we probably won't lose marks for that. So it's going to come down. It's going to go back up. Okay, that's not bad. I'll take that. That's my quadratic. I should really make it so that it goes through the point perfectly. You know, I'm doing it on a screen here. It's a bit easier when you've got a pencil, and that point should go perfectly through there. Okay, there we go. There's a sketch, and that's one reason why using completed square form is useful. There are lots of other reasons, but we get a nice sketch. We don't actually have the roots where it crosses the x-axis. That would be when you set it equal to 0, but we're not focusing on that here because it asked us for the y-intercept, which we have, and the turning point, which we also have.